Welcome back to Applied Physics Lecture Series, Unit 3 Optoelectronics, Lecture 5, Semiconductor Laser, its Principle, Working and Characteristics. So, before going to the semiconductor laser, first of all, you have to recollect what is the abbreviation or acronym of laser. So, laser is nothing but light amplification by stimulated emission of radiation. Therefore, to produce the laser light, you have to conduct the process of stimulated emission. So if you consider the semiconductor laser, there are two types. Except the construction, principle and working are same for both. Except the construction, principle and working are same for both. So here the two types of semiconductor lasers are. First one is homojunction semiconductor laser. Second one is heterojunction semiconductor laser. A homojunction uses the same semiconducting material with a different doping on both sides of the junction. But in a heterojunction, uses two semiconducting materials having different band gap energies on both sides of the junction. What is the basic principle behind the production of this semiconductor laser? If you consider the conventional lasers like solid state laser and gas laser, examples are ruby laser and helium neon laser. Laser light is generated due to the transition of electrons from higher energy level to lower energy level. That means once the pumping process is over, population inversion is achieved. As a result of such a population inversion, we will conduct the process of stimulated emission. Then during the process of stimulated emission, the electrons are returned back to the ground state. So as a result, we will get coherent photons. This is the principle involved in the conventional laser production. But in case of semiconductors, laser transition of charge carriers takes place from conduction band to the valence band. That means rather than from higher energy level to lower energy level, here in case of semiconductor lasers, the transition will take place from conduction band to the valence band. Laser light is produced due to the recombination of electrons and holes at p-n junction when current is passed through the diode. So here recombination takes place. So once charge carriers are generated, then we will know the process of recombination, and during the process of recombination, electrons and holes are recombined at the p-n junction. As a result, laser light will be produced if you pass the current through the diode. So laser light is due to stimulated emission. Wherein current is passed through the p-n junction under forward bias, the injected electrons and holes will increase the density of electrons in the conduction band and holes in valence band. This is quite similar to the generation of charge carriers. As the current is further increased at some threshold value of current, amplification takes place and laser begin to emit coherent radiation. So the properties of semiconductor laser depends upon the energy gap. Here you have to know what is meant by amplification. With the minimum input, you have to get maximum output. That is the exact meaning of amplification in the scenario of lasers. And if you want to construct the semiconductor laser, this is schematic diagram represents the construction part of the semiconductor laser. If you observe this diagram, here we are having a p-n junction diode. So p-type material is there and n-type material is there. In between those two, there is active material. And at the bottom of n-type material, there will be a metal contact. And even at the top of the p-type material also, there is a metal contact. And the bottom is a polarized phase. That means a polished phase. The N material is completely polished and roughened phase, whereas the p-type material is partially polished. And this p-n junction diode is connected to the forward bias. Under no bias condition, so there is no recombination of electrons from conduction band to the valence band at the p-n junction region, that is in between the junction. So as a result, there is no. But in case of forward bias, we will see the population inversion. As a result, more and more number of charge carriers are ready. Then there is a possibility to conduct the process of recombination. So if you consider the working process, so when the junction is forward biased, electrons from N region and holes from P region move to cross the junction in opposite directions. Because of opposite polarities, opposite charges possessed by both the charge carriers, both are moving in opposite directions. In the junction region, the electrons and holes recombine due to the transition of electrons from conduction band to valence band. So at one threshold value of current applied, so electrons and holes are recombined due to the transition of electrons from conduction band to the valence band. For low currents, population inversion does not take place, hence only spontaneous emission takes place and the photons released are not coherent. In order to get the coherent photons, definitely have to increase the current. That's why when forward current is further increased beyond the certain threshold value, population inversion takes place and coherent photons are released. If you consider the energy gap of gallium arsenide is 1.487 electron volts, and the corresponding wavelength of radiation we are getting is 6435 angstrom units, which is responsible for laser emission. And if you consider the main characteristics of the semiconductor laser, so here also the characteristics are quite similar to the conventional lasers. So we're expecting unidirectionality. That means laser light is traveled in a single path in only one direction, and negligible divergence. Angle of divergence is very, very small. Deviation is very, very small. And it is also having high intensity, and it is having high degree of coherence. And the last one is monochromatic. It is exhibiting only one color. The traditional lasers and modern lasers at a time they are exhibiting only one color. That's why they are truly monochromatic. And if we consider the applications of semiconductor lasers, so semiconductor lasers in fact are used in many areas like communication, medical, industry, chemical and biological applications. And if you consider the LED and semiconductor laser, what is the necessity of comparing these two only? Because both are operated under forward bias, both are nothing but both are having PN junction diodes, and both are operated under forward bias. That's why we have to compare certain parameters between laser light and LED light. So what are the parameters we are taking to compare? First one is material. So both LED and laser, they contain PN junction diodes. And if we consider the parameter as biasing, both are operated under forward bias. And if we consider the principle as a parameter as a principle, LED works with spontaneous emission, whereas laser works with stimulated emission. And the parameter is coherence, and usually from LED, so the principle is a spontaneous emission. That's why we are getting incoherent photons. But in case of laser, the principle is a stimulated emission. As a result, we will get coherent photons. So here we have to remember one thumb rule: during the process of stimulated emission only, we will get coherent photons. Our laser light consists of only coherent photons. And if we consider the another parameter is directionality, usually LED is non-directional. That means the light output from the LED is deviated in all possible directions. But whereas the light output from the laser device is traveled in only one direction, that means it is unidirectionality. Thanks for watching.